Okay, real quick, we're back in chapter 6. We're on the dual problem, which is minimization. And I give you a quick summary of the simplex method. You can read through it if you want. We've talked about setting the dual problem up, and Roman numeral 2 is how to set it all up. You have to have a minimize, an objective function, and your constraints have to be of the form greater than or equal to. When you form the initial matrix A, you're going to put your two constraints in, or however many constraints you have. You're going to put just the coefficients as your rows. Then you put your objective function as your bottom row, 21, 50, and 1. Then you write the transpose of the matrix. When you transpose a matrix, the row becomes a column. Once you get the transpose, you're going to write the dual problem, meaning this. You're going to turn it into a maximize problem. And you're going to maximize down here, 12y1 plus 17y2, subject to these two constraints. And the constraints now have less than or equal to. So when you have a minimized problem, you have to write the matrix A, then you have to find a transpose, then you write the dual problem. Once you have the dual problem, you proceed like we did last week, where you have to write slack variables, form the initial simplex table, find the most negative indicator, that's the pivot column, go divide the last number by the number in the pivot column. As long as it's not 0 and not negative, you throw those out. You find the smallest number, and that becomes your pivot row. This is your pivot. Now you're going to be at an advantage because I will push a program down to your calculator. You're going to put this matrix in matrix A. Then you're going to run the simplex program. And it will give you the final simplex table, which is down here. When you have the final simplex table, notice that your y1 and y2, those correspond to the dual problem, right? And your old variables, x1 and x2, are the remaining columns. And then your objective function is here. To read the answer to the dual problem, your P, which is this number 1 here, is 121. For that linear programming problem, the objective function is minimized, and the minimum value is 121. When x1 is 1 and x2 is 2. You don't care that there's ones and zeros here. For the dual problem, you literally look at the bottom of the column, and those are your answers. So let's go walk through an entire problem. Go minimize. So the first thing we need to do is build the matrix A. Matrix A will be 2, 1, 5, 20. You see where I got that from the first constraint? The second row will be 4, 1, 1, 30. And your last row comes from the objective function 40, 12, 40, and 1. That is matrix A. Good. Now go write matrix A transpose. Write the first row as the first column. 2, 1, 5, 20. 4, 1, 1, 30. And 40, 12, 40, 1. A was a 3 by 4 matrix, and A transpose will be a 4 by 3 matrix. Now you can write the dual problem. What is the dual problem? You want to maximize P equals, down at the bottom, 20y1 plus 30y2. We clear on that? Subject 2. How many constraints are we going to have? How many rows are above that? 3. We're going to have 3 constraints. You're going to have 2y1 plus 4y2 less than or equal to 40. You're going to have 1y1 plus 1y2 less than or equal to 12. And 5y1 plus 1y2 less than or equal to 40. y1 and y2 both have to be non-negative. That is the dual problem. The next step is to write the initial simplex table using that dual problem. So my matrix, I'm going to have columns y1, y2, and there's 3 constraints, right? So I'm going to have to add how many slack variables? 3. And I'm going to title those x1, x2, x3, and then p. My first row of my initial simplex table will be 2, 4, my first slack variable, those 2 slacks are 0, p is 0, and my last column is 40. Right? Because the corresponding E system would say 2y1 plus 4y2 plus x1 equals 40. The second row will be 1, 1, 0, 1, 0, 0, 12. This is the second slack variable. For your third constraint, 5, 1, 0, 0, 1, that's your third slack variable, 0, 40. Your bottom row, how do you get it? It's the objective function. I need to move everything over to the left of the equal sign. So I would get negative 20, negative 30, 0, 0, 0, 1, 0. Are we good setting up the initial simplex table? Okay, other questions that I will ask. Where is the pivot column? Underneath Y2, the second column, because this is the most negative number down here. So my pivot column is there. To find the pivot row, I'm going to do 40 divided by 4, which is 10, 12 divided by 1, which is 12, and 40 divided by 1, which is 40. What's the smallest number? 10. So row 1 is my pivot row. If I ask you to identify the pivot is this number 4 in row 1, column 2. We good? All right, if you were solving this by hand, you would need to do 3 row operations. You would need to get that 4 to turn into a 1, so I would multiply row 1 by 1/4 and make it my new row 1. Then I would take that 1 and turn the 1s underneath it into zeros, and that negative 30 into a 0. So I would need to do negative 1 row 1 plus row 2 to become row 2. I would need to do negative 1 row 1 plus row 3 and become row 3. And I would need to do 30 row 1 plus row 4 to become row 4.
Could you do the first two at once? Because they're both times -1 or not?
Nope, you're going to have to put them in your calculator separately. That's going to give you another matrix. And guess what? That matrix is still going to have a negative number down there. So you would have to do it again. Let's go look. Second matrix. Edit. Okay, what size is this initial one? 1, 2, 3, 4 rows. 1, 2, 3, 4, 5, 6, 7 columns. It's a 4 by 7. No. 4 by 7. All right, and I have the matrix here. 2, 4, 1, 0, 0, 0, 40. All right. 1, 1, 0, 1, 0, 0, 12. 5, 1, and the last row is -20, -30, 0, 0, 0, 1, 0. Does that look right? Yes. All right. Once I push this program to you, you're going to hit Program Simplex and hit Enter. Do you see any more negative numbers down on the bottom row? No, you're done. Now, if you hit Enter again, it's going to turn everything into a fraction. And then it'll say done. Okay, so let's go copy that matrix down on our paper. We have 0, 1, 1/2, -1, 0, 0, 8. Then we have 1, 0, -1/2, 2, 0, 0, 4. 0, 0, 2, -9, 1, 0, 12. 0, 0, 5, 10, 0, 1. All right, remember the columns, Y1, Y2, X1, X2, X3, P. All right, the answer to this linear programming problem, the minimum is 320. You got that from here, which occurs when X1, X2, and X3 are what? 5, 10, and 0. Now go back to your problem. The problem were in X's, right? How many X's were there? 3. How many X's did we put in our answer? 3. Got it? All right. Had you done the row operations on matrix A, so just to show you, matrix A, do you remember the row operations? There were 4 of them, right? These 4 here. I'm going to go type those in. Just watch. Math, multiply a row by 1/4 in matrix A, row 1. Store that as matrix B. Then I'm going to go do multiply, add a row and it was by the number -1 in matrix B, row 1, and add it to row 2. Is that right? 1 to 2, yep. And store that as matrix C. Go do matrix math, multiply, add by -1, matrix C, row 1 to row 3, store it as matrix D. Last one, go do matrix math, multiply, add by 30 in matrix D, row 1 to row 4. Store it as matrix E. Do you see we would need to do a pivot again? Why? There's a negative in your indicator row. What would be your pivot column? Pivot column would be column 1. If you did 10 divided by 1/2, you'd get 20. 2 divided by 1/2, you'd get 4. 30 divided by 4.5, you'd get 6 something. What's the smallest? Row 2. So what is your pivot? 0.5, right here. This one, in column 1, row 2. Now, which way is easier? The Simplex method program, if you're lucky enough to have it. All right. That's all I have for that problem.